Students, I am doing sum number 15 of 14C. So the diagram is ready. I am given that ABCD is a parallelogram and AP is the bisector of angle A and CQ is the bisector of angle C. And I have to prove that AP, C and Q is a parallelogram. So for that we need to do a construction. We have to join AC and both the diagonals will intersect at O. So please write down join AC and both the diagonals intersecting at O. Now we know that angle DAB, this full angle A, is equal to full angle C because they are opposite angles of a parallelogram. Opposite angles of a parallelogram are equal. Then if full angles are equal, so half angles will also be equal. So if I see AP is the bisector, so half of angle DAB will become DAP, and here half of angle this full C will become BCQ. So if DAB is equal to DCB, half of angle DAB is equal to half of angle DCB, and half of angle DAB is DAP, and half of angle DCB is DC and Q. So I proved it. So you will just write your reasons given that they are bisectors of the respective angles. Now come to your two triangles DAP and BCQ. These are the two triangles I am looking at, DAP and BCQ. First two conditions are very easy. I have proved this condition. This angle is equal to this angle. I have already proved it. DAP is equal to BCQ. You can write proved earlier. I can prove that AD is equal to BC because they are opposite sides of a parallelogram. And my third condition is the alternate angle. So I can write that this angle is equal to this angle as they are alternate interior angles. So I have written angle ADP is equal to angle QBC, alternate interior angles. So both my angles are congruent, triangles are congruent by which test? They are congruent by ASA test. So therefore triangle DAP is congruent to triangle BCQ by ASA test. Because of this, I get my DP is equal to QB CPCTC. Because of proving this, I get my DP is equal to BQ, which is CPCTC. Now why did I do this whole thing is I want to prove that this is a parallelogram. So if I prove that the diagonals bisect each other, then this quadrilateral becomes a parallelogram. So if already ABCD is a parallelogram, so OB is equal to OD, and I have proved that DP is equal to BQ. So if I subtract the equal portions from it, I get OP is equal to OQ. And OA is already equal to OC because it is the diagonal of the existing parallelogram. So if I prove that the diagonals bisect each other, this becomes a parallelogram. Let us see the steps. So I already have OD is equal to OB, diagonals of parallelogram bisect each other. So then you can just repeat your DP is equal to QB. You have proved earlier. You can number them as 1 and 2, and 1 minus 2 will give me, so OD minus DP will give you OP. OD minus DP will give you OP, which is equal to, and then other side I get OB minus QB, which is equal to OQ. When I subtract 1 and 2, I get this. And also I have, I'm continuing it on the next page. Also I have OA is equal to OC because they are the diagonals of the parallelogram ABCD bisect each other. So So here OA is equal to OC because they are diagonals of ABCD, they bisect each other. Now I have proved OP is equal to OQ and OA is equal to OC. Hence APCQ is also a parallelogram as their diagonals are bisecting each other. Just finish it in the end, since you have proved that both the paths are equal and the diagonals are bisecting each other. APCQ is a parallelogram.